Right now, we're going to look at what to do if our data value does not fall right at a standard deviation line like it did in question number 4. So if we wind up having a data value that falls somewhere in between 2 and 3 standard deviations, the empirical rule wouldn't help us. Okay. All right, so we're using this table, table 16. You also have access to this when you're doing the homework. You need to understand that the table is always, if you have a z-score, let's say your z-score is 1.12. So for a z of 1.12, this A we get is the relative area under the curve, okay, always from that z-score to the mean. So it would be this, always from your z-score to the center. So it's assuming that the area under the curve is understood to be one whole, then the decimal that would represent the relative area under the curve would be 0.369, okay? Or if you thought of this as being 100% of the data values, then 36.9% would be 36.9% of the data values. They would fall between the mean and 1.12 standard deviations above the mean. So this value we get out of the table, this A, can stand for the area under the curve as a decimal. It can stand for the percentage of data values you would find in that region. Or you can think of it like the probability that a data value would be in that region. So let's go ahead and learn to make use of this. All right. So these problems right here, we're going to have to refer back to the table to get these A values. All right. So here we wanted to know the percent of scores that would lie between the mean and 1.5 standard deviations above the mean. The mean is always at the middle. What you see shaded is what we're looking for. So we would take our z-score of 1.5 and we would go to a table. So I pulled up the table. See if I can get back to it. I have the tables from the homework. Let me get back to them. All right, and I'm looking for 1.5. There it is right here. Right here, okay? And right there I see that 1.5 has a corresponding A value of 0.433. I can't write on it, apparently. So, but you see what I'm talking about? I've got my cursor kind of there. See that? 1.5, 0.433. So let me go back and write down that. So the A value that I found was 0.433. Now this one said find the percent of scores that would lie between there. So that would be 43.3%. So we're claiming that 43.3% of the data values would fall between the mean and 1.5 standard deviations above the mean. Now here we want to know the percent of scores that lie between the mean and 2.62 standard deviations below the mean. So that's over here. So it's a negative value. Well, when I try to go do that, I don't see any negatives, right? There aren't any negatives there, okay? I'm also going to need the other page. So let me go into this problem and see if I can get page 2. So the z-score was a negative, which I don't see negatives in there, but that's okay. I'm just going to go to 2.62. So that's down here. See my cursor down there? That's 0.496. So that 0.496 would represent, if it was a positive 2.62, that there would be the A. So when Z was 2.62, the A was 0.496, which means that when I'm here on the at 2.62, this shaded region would be 49 point, where you would find 49.6% of the data values. But because of symmetry, we know that's going to be true over here as well. So that's why you don't need the negatives. You just go to the positive one, and you're still going to be able to get the percent of the scores that would be between negative 2.62 and the mean. So it'd be 49.6%. Okay. All right, now down here, a slight difference in wording. This is saying total area that is shaded. And that really is a relative area as compared to the whole being 1. Typically, when you see them use the word area, our answer is going to be the decimal form, not the percent form. All right, so think about your strategy here. You're going to take your z-score of 2.55 and your z-score of negative 1.7, and you're going to get the a value for each of those. Okay, so you've got the table. It's probably easier for you to do it than to look at me trying to do it on this. But I'm going to go to where 2.55 is, and I see 0.495. 0.495. And when I go to, remember, I don't need to worry about the fact it's negative. I'm just going to go to 1.7. So I need to go to the first page. Let's see, where's my first page? Okay. And it was 1.7, so I need to look at that one. That's right here, 0.455. 0.455. Okay. So when you're thinking about this, the 0.495 or 49.5% would be this. From 2.55 to the mean would be 49.5%. And then 45.5% of the data would fall between a negative 1.7 and the mean. Now, when you look at this picture, do you see how we would need to add those two to get the percent that would fall from the negative 1.7 all the way to the z-score of 2.55? All right, so we would add them. So we would expect we would expect 80, 94, 95% of the data to fall between those two. But it said area. We'd expect 95% of the data to be there. So the area under the curve is 0.95. That's kind of relative area. That's assuming the whole was 1. You just change it into a decimal. And your answer, if it says area, your answer should be the decimal. Let me write that better. So that would be that. Okay? All right, so you're going to do the same thing on this one. You're going to take a z of 2.63, a z of 0.61. Now that you've seen how to do it, just go to the table and get the a value that matches up with that. So take a moment to do that. Pause the video and then check. So it's 0.496, and the a value corresponding to a 0.61 should have been 0.229. Okay. And you got to keep straight where you are in the process. So we had our z-scores, now we have our a values. All right, now, when you look at this, from the 2.63 all the way to the mean, that would have been 49.6% of the data values. Then from this 0.61 to the mean is this part right here. Okay, so this is 22.9% of the data values, where all of this, not just the shaded part, but everything in blue, was 49.6%. So that was everything in blue. So if I want that shaded region, do you see how the picture shows you? If you want just the shaded region, wouldn't you have to subtract off this part right here? That part right there? You would want to subtract off. So you had your blue, you had this being your blue, you had this being your green. You would need to subtract off that. Take that green away. Subtract that. And so that's exactly what we're going to wind up doing. So we're going to take the 49.6, which is from 2.63 all the way to the mean, and we're going to subtract the 22.9% from it. And when we do that, we get 26.7%. But it was in terms of area, so you would change that to or use the decimal 0.267. You really could have just subtracted this decimal number and that decimal number. I can do better if I've got it as a percent first, but you could have just taken 0.496 minus 0.229. Now, just an observation, notice they're on the same side of the mean. That's when you're going to need to subtract. Notice on number 6 that the data value, that the z-scores were on opposite sides of the mean. Okay, that's why you add. Same side of the mean, that's why you subtract. Right? Now look at number 8. We have a z-score right here that's 2.14. So you can go to your table, and when you do, you get 0.484. Okay? 0.484 would represent this. Okay? Because that's what the table can do. That's all it can do, is from your z-score to the mean. But that's not what you want. You want what you see shaded. Well, remember how from here to there would be 50%, right? Let me do it in green. Isn't this 50%? Everything to the right is 50%. So what we would need to do is take 50% and subtract the 48.4%. And when we do, we would get 1.6%. So that means the gray area that you see right here, this must be 1.6%. So 1.6% of the data value should fall there. And then it is using the word area, so we'll report it as a decimal. Okay. All right, so one of the things on this page is that we already had z-scores. All right, so let's do a couple more where we already have z-scores. All right, so this one is asking us, find the percentage of the area under a normal curve between the mean and 0.11 standard deviations below the mean. So 0.11 would be just slightly to the left of 0. And you want the area under the curve between the mean and that. So you are really this is standard deviations below the mean. So that's telling you your z-score is a negative 0.11. So go to 0.11 and get your a value. And it turns out to be 0.044. Let me double check that real quick. Let me go back to my table. 0.11. That, yep, 0.044. Okay. And I wanted the area between the mean and 0.11 standard deviations below the mean. So these problems don't have the picture drawn. You need to draw the picture. It really helps. And so that's exactly what the table would do us. We do want a percentage, so we'll change that to 4.4%. And we got it. All right, now here we're being given the z, but we don't have the drawing. So 1.75 would be about right there. And negative 0.64 would not quite be to 1. It'd be a little over halfway. So you need to think about this and shade that and look at it. So then get your a values associated with each of these z's. Okay, so the a for the negative 0.64 was 0.239, and the a for 1.75 was 0.460. Okay, so we have a 23.9% of the data values would be there. Okay, and approximately 46% would fall on here. And you notice those z-scores were on opposite sides of the mean. Notice to get the percentage of the area that would be between those two, you would need to add those two. And they do want a percentage, so just leave it as a percent. And you wind up getting 69.9%. Okay, let's do one more where you have the z, but they haven't drawn the picture for you. You need to shade so you know what you're looking for. So on this one, we want to know the fraction of area under the curve. It can still be a decimal, but they don't want a percentage is the key. To the right of z equals 2.93. So 2.93 is close to 3, closer than I'm even making it. But we want just what's in that tail right there. So take your z, find the a corresponding to it, and it turns out to be 0.498, 0.498. Okay, so what that really is, that 49.8% really is it's the percentage of data values that would be here. It's not what I want. I want the percentage that would be there. So since 50% of the data values would be above the mean, then I could take 50% and subtract the 49.8%. And that would wind up giving me, in this case, just 0.2%, just a smidgen. But it did want it as a decimal number, like a fraction, rather than a fraction of the area rather than a percent. So I'm going to do the same thing I did before to change it to a percent. Move the decimal 2 places, and it would turn out to be 0.002 would be the little bit, the fraction of the whole that would be located here. It would just be 0.2% in that tail, which corresponds to 0.002.